Hello, everyone. Up next, we will have an intense conversation between Asad from Okto and Apriori from Anoma about intents, the current state and the future state and the applications that can be built with them and everything else surrounding the space. Enjoy.
Test.
Test.
It's bright up here.
Yeah. So I think let's get started. I think we'll just start with some introduction. So hi, I'm Asad. I'm the architect at Okto. So what we do at Okto, we are basically building an end-to-end chain abstraction stack, which allows developers to build one-click experiences and simplify users' life. So Apriori.
My name is Apriori. I work on Anoma. My official title is Head of Research Relations, but you could think of me kind of as like Rick Rubin. We are building a distributed operating system, and the key insight here is it allows you to abstract over a variety of different chains or other computers that are running the Anoma protocol and treat it as one unified execution environment.
Awesome. So I think the talk today is all about intents. So what we have seen in the last few years that users have been focused on interaction or transaction-based model because where they know what they want and they're trying very hard to achieve that. But we are seeing a shift towards intent-based interactions from the user side. And while building Anoma, you would have made certain design choices at your side. We were curious to know what were the different choices of architecture you were considering while building an intent-centric network, and what made you arise to the one that you have today?
Yeah, that's a good question. So I would just caveat and say that we don't have a live in production system yet. We do have open source code with a client written in Elixir, so you can check out the Node software and run it yourself if you like. We also do have a private DevNet for our builders program. So I just want to caveat that for folks. I would say there's kind of two components to the Anoma protocol. There is an off-chain component if you want to think about in terms of how people use the word on-chain and off-chain. So this would be like a peer-to-peer intent gossip layer where there's counterparty discovery between different agents. So you could think of these agents as like solvers, as we've called them. And by solver, I mean more so like a capital S solver. So this role could encompass something like computational search. It could encompass routing intents to the right application for solvers. It could encompass providing liquidity or selecting the optimal batch of intents to batch for ordering and execution. And so the second part of the protocol is settlement. And so this settlement can happen on any blockchain that is running the Anoma protocol. So this could be like Ethereum main chain, an Ethereum rollup, or it could also be another chain that is running the Anoma native software stack itself.
Awesome. So to just understand a bit deeper on this one, when you talk about intents and the level of intents that these solvers can do, what sort of applications do you see people or sort of intents that is Anoma best fit for solving for, whereas certain use cases where Anoma might be an overkill or a solver network might be an overkill to solve for those intents?
Yeah, that's a really good question. I think one of the nice things about the emergence of intents, and shout out to all the people that have really been putting in a lot of work, whether that's the folks at Across, the folks at Near, other folks that are working on this CowSwap, et cetera. One of the nice things about intents is that they allow the user to no longer have to worry about how to get what they want, but just to express what it is that they want. And this is a bit of a mindset shift for a lot of legacy Web3 users, but it's a necessary one if we're actually going to expand and hit some of this total addressable market that we all seem to be thinking about. So to answer your question a little bit more specifically, the Anoma protocol is quite general. So it could be any kind of intent. It could be something like an intent for a swap. So you could think of this like a limit order. It could be an intent application that has some custom ordering invariance. So you have to run a particular type of auction and order intents in a specific type of way. So that could be one use case, which is it's really well suited for. Another could be for something like a messaging protocol or something like a crowdfunding protocol or any other kind of like conditional commitment that you want to make that requires some kind of gossiping around and finding a counterparty. Intents, while they are really well understood in the interop sense in terms of going from, let's say, Arbitrum to Base, they're actually a lot more useful in the scenarios where you're looking for like ring trades or coincidence of wants, ways to aggregate, offset different sources of liquidity, and find different counterparties. So they're really most useful, I would say, in multi-party applications.
So one of the things that we were considering while building Okto is that for us, we took a different approach of instead of building a generic intent solver, we started building our own solver network which works on primitives. So these primitives are called blocks, and these are basically like Lego blocks that allows users to operate on different intents like trade, swap, interact with a certain protocol, like Hyperliquid for that matter, and the protocol the solver is fairly extendable, so that people can combine bunch of blocks together to build their own composable flows and build on top of it. So this allows for us in our experience, what we have seen is a lot of users are doing a lot of repetitive intents. For example, a GameFi application might be just doing a bunch of NFT transfers over and over again, or might be having like a delayed settlement when the game gets over. So such use cases is more lifecycle oriented, where you have to ensure the transaction goes through. So we track matrices like lower latency, lower computational resource. So we're curious to know about when we talk about intents built on top of Anoma. Thinking about liquidity intents is what 7683 and other folks are also solving for. What are the specific intents that you feel that, apart from liquidity, what are the other things that you feel that is very cool to build on top of Anoma?
Yeah, I think in terms of potentially stacking multiple actions on top of each other, I mean, I think this is something that people have been trying to play with for the last couple of years, whether they've called it like ZKML or AI agents or something like this. And there's also different flavors of this in account abstraction where you have different types of meta transactions. There are different systems in place today where you might craft a meta transaction to, let's say, take out a flash loan, leverage loop your DAI, and then deposit it in a vault. These are the types of use cases which I think are kind of interesting, where you can maybe do a swap and then deposit. There are some systems actually live in production today. Shout out to Enzo. They make it actually really easy to integrate with their API, and you could actually call that API and do something like do a swap and then deposit it in an Aave contract, let's just say. So I think the actions where you have multiple things stacked on top of each other could be very interesting, given that everybody has some kind of unique preference. And the way that users use DeFi today very often is they'll go to one destination, one front end, do one thing, go to the next destination, next front end, do the next thing, and then they might even do a third thing. And being able to abstract that away and also do it with one signature and not have to have this workflow where you have an approved signature and then a transaction signature, where oftentimes the user doesn't even know what they're signing. I think in these particular examples, they could be interesting. But I have more specific app examples if you're interested.
So I think one of the applications that we have been built on top of us is, say, a GameFi application, or say something which is very useful and live today as well in Okto app is people might have liquidity across different chains, say Solana, Aptos, whatnot, and suddenly Hyperliquid is something that is just popping up, and people were just wanted to trade on Hyperliquid. So one of the intents that we enabled was, why don't we aggregate liquidity from different chains, deposit in Hyperliquid, and what we requested them was just give us how much USDC worth of trade you want to make on Hyperliquid, and let us take care of the flow and the gas and all the lifecycle management that goes behind it to ensure that user is able to make a one-click trade with his balance spread across multiple chains. I think that was pretty useful for the users because they had the intent, they don't need to worry about how to actually use a protocol, but we enabled them to use the protocol. So I think that is pretty powerful from a user, but as well as a developer's perspective.
Definitely.
Moving on to the workflows that we just talked about, stacking intents, making complicated workflows happen. It seems very useful for the end user, but it is equally difficult for a solver to come across to make those things happen. And especially when we have a network like these, verifiability becomes a true challenge there, where we have to verify that things have went through as it was intended by the user. So one of the things that we have been grappling inside our company as well is to how do we make solvers truly verifiable. And ZK might be one way of doing things, but it's not there yet in terms of the resources that it consumes today to prove what you have done is right. we resorted to make it a T-based approach where we verify that the solver has done the right computation as per the primitive that we have already defined. So because we have done the primitive, we have audited those primitives, we just want to ensure that it has been done in a non-corrupt, non-adversarial, secure computation environment so we can trust it has come across the right payloads. So curious to know about verifiability at your side.
Yeah, that's a good question. I'd say I'll try to explain how we're thinking about solving because I think that might be helpful. So today, when people say solving in Ethereum land, really what they mean is either somebody who is doing the on-chain routing, finding the best path, optimal path to liquidity. So this could be something like a DEX aggregator or something like Propeller Swap. Or they mean maybe like a market maker that is actually taking on an inventory risk and also pricing opportunities with an order book with liquidity that might be both on Binance but on chain or in some third place. And then you also have the notion of a relayer or a filler. And this would be somebody usually that takes on inventory risk of the same token, but they might hold it across different chains. And so when you're doing those routes from Arbitrum to Base, if they become very popular, they need to rebalance and get their tokens on the right chain so they can then compete and fulfill the user intent in the next auction. So how we think about solvers is very much in this decompositional way. And so you'll have somebody that's routing intents, you'll have somebody who's doing computational search, you'll have somebody that's providing liquidity, and then you'll have somebody who's selecting that batch of intents, depending on the invariance of the auction. And so in this process, this could be logically one entity, right? This could be like a Coinbase mega solver, or this actually could be different entities that are competing for these different opportunities if the economics make sense for them. And I think we still have a lot to prove in terms of the economics of intents. So if you think about solvers and just say it's this one bucket position, you can think about two things that we've spent a lot of time on. We've looked at private solving. We've also looked at verifiability. So for private solving, we've done some research into MPC. Also, we've looked at witness encryption as well. And then in terms of verifiability, we've looked at TEs, and we've also built out the resource machine with a backend with a Cairo zkVM, but then also we have one that we're working on with a RISC-0 zkVM. And this would be for verifying Anoma formatted intents on a particular chain, let's just say. So you could verify that the solvers do actually meet the invariance of the intents by having some standardized approach. So that could be with some abstraction that somebody built, or it could be with the Anoma resource machine that's deployed as a set of contracts on maybe Ethereum mainnet, Ethereum rollups, and then in the future it could be other places as well. But we're more so focused on Ethereum.
So when we talk about, say, a user intending to have an action A, and suppose the solver ended up doing B, so where does the verifiability come into play? So for us, we verify whether it really created the payload for A or not, because it's primitives. But when it is a collaboration of solvers coming together trying to solve something, it may have missed a slippage, or it has maybe missed something off a mark, like, or maybe did some wrong token for a chance. So how do you exactly match A to B, whether the intent has been verified or solved or not?
So intents, you could think of like the way that they are actually represented as partial transactions. So in order to match these partial transactions, you actually have to create a proof. So in that process of making a proof, you can then verify that those partial transactions were matched and adhered to the invariance or the constraints.
So as a user, when they're defining an intent onto the network, they have to actually define each of the steps and verifying that partial proof against it?
So the user could produce a proof client side. And then a solver could come up with a matching partial transaction. And then as soon as, whether it's like a pre-confirmation system that the solver could issue if they're offering their own liquidity, the user's client would update and tell them, hey, we can verify that the solver did match this intent, and here's the accompanying hash of the zero knowledge proof. Or you could wait for verification on chain. So you could wait for an Ethereum block number at a particular height, and then you could see that that proof was verified by the verifier contract.
Awesome. So this way you could actually it's up to the solvers. If they want to have faster verification, they have to pay for it. Otherwise, you can wait for the full confirmation to happen.
Yeah, that's right.
So it's a neat approach to take. Going through the same flows, I think when a user have an intention to perform, say, take withdrawal from my vault or the amount that I've staked, move it across some other chain and deposit in some other vault. This could be the fairly intents that people can build on top of it. Like this could be the workflows that people are building. How do you see the role of assets and access to wallets in this realm? Because resource lock is what people are talking about right now when they're talking about cross-chain liquidity intents. But when we actually want a solver to act upon some micro transactions that they want to do, which can only be done via the same wallet of the user. So how do you consider this access to assets or access to wallets by a solver for a given user?
Yeah, you could do a couple things. You could either think of an intent like as a binding conditional commitment. So this would kind of be like a resource lock. So you could just delegate to a resource lock account, and then a solver could know that you're not going to equivocate. And I think that's probably, at least in the near term, the most practical example that we'll see. You could also delegate to, like, say, a permission set of solvers for a particular application, or maybe they're a solver that specializes in like 10 applications that you like to use, let's just say. Maybe there's some economies of scale in solving for all of them. And maybe in that, it's a session where you delegate permissions for, I don't know, 30 minutes or something in order to execute your intent at the optimal rate. Let's say it's a swap, or maybe you're trying to get the best lending rate possible or something like this. Or maybe you just want an average price fill at like a TWAM, like a particular tick. So yeah, I think there's a couple different approaches you could take there.
I think you briefly mentioned about session delegation and time-based limits as well. I think this is something that we spent our hard work for the past 2 years building out a network that allows users to have delegated access over EOAs. So we have like an MPC network, which you can have like a session key. And this session key is time-bounded and dollar-bounded. So you can just say that up to $1,000, it's accessible across all the networks or a defined networks that you users preference about it. And up to say 2 days or 30 minutes, they can just give a session key to a given solver, and then the solver can act upon it basically. So I see we have some synergies out there.
Definitely. I mean, if you think about these problems long enough, a lot of them lead to the same roads. I also think too, one of the nice benefits of intents is, again, like really just focusing on what the user wants. And there's a lot of different ways that wallets can help facilitate this. And I think we're going to see probably somewhat of an arms race for who can build the best comprehensive wallet that integrates things like natural language, but also one-click intents as well. And I think the space there is wide open. I don't think anybody's won that marketplace yet.
Awesome. So I think we are about time. I think the parting notes would be that you had a private DevNet up. So would love to see, in your experience, what was the most bang-on dApp that you see built on DevNet, which maybe if they wouldn't have been able to build without Anoma? And what do you see the future of intent-centric architecture?
Sure. So I'll shout out a team that's building on the private DevNet called AnyType, and they're building a chat application, and they are trying to focus primarily on end-to-end encryption, and also starting with a very local market in Berlin, and then kind of building out from there. So trying to find product market fit, and then scaling. There's another team, MyCell, that's working on this concept of like a transferable account. So you could like transfer a portfolio of assets across different chains using intents. So I think those are two cool projects.
Awesome. So we have, on similar lines of chat application, we have something called Stan. So Stan is the Southeast Asia's largest fan engagement platform. So they have built out completely an intent-based application to engage with their fans in different games and different NFTs form. So I think that is a pretty cool use case that we have seen having product market fit for intent-centric applications. Awesome.
Definitely.